adverts. What is it? Nah, it must be World of Warcraft or something stupid, I don't know. Ah, well, lovely. Oh, hey, that's working. And the sound is. Interesting. Oh, let's settle in. Let's settle in. We're live. Ugh. Let's see if my computer's gone to sleep now, shall we? Yes, it has. Let's see what we can do today, huh? Ooh, that's nice. Oh, that's even better. We've got a computer. That's nice. Let's have a look what we're doing. Metal Rogue. Research. How did the research go? Let's have a look at thing. No, okay. I'll just check it out. It's all right. It should be okay. Okay, we got succeeded anyway. So I was messing about, and this is what I came up with, which we won't be using. But I want to show you what happens first. So I started with this view controller, and as you can see, it got a bit small. How it's done is by making a renderer hopping the device over, that'll initialize the rendering, and then setting a view delegate. Now the view delegate is then held in rendering, which is, yeah, that's here. So it's this extension thing here. This is the view delegate, and what happens in here is it does the rendering. Or does it? No, it doesn't. It does everything but the rendering, because the rendering has been passed off to scene render. So we go over to scene render, and it's not there, because scene inherits from node. This is called a scene graph. Ah, function render at long last. Oh, wait a minute, it's for all the children. Right, so this must be an override. All the good stuff's in here. Here's a renderer. No, that just does encoders. Okay, let's have a look at a primitive. Oh, that doesn't do much either. Where is it? Where's the command to render? Did I just miss something? Is it in basic scene? No. Where is it? This is the problem. I don't know where the hell it is. I've already lost track of what the hell is going on with this scene graph. So this is why we're not using it. It's because I can't bloody find anything. What does it do? Let's have a look. Does it actually render? I mean, have I just lost it completely? Oh yeah, it renders alright. There you go, that's what it does. Tell you what, let's not do that. Just let's not do that, because I can't cope with... Well, what's the problem? The real problem is at the top. It's nothing to do with what's at the bottom. It's here. We have rendering is an NS object. We have node, which is a node class. We have scene, which is a node. We have basic scene, which is a scene. You're getting the point. We've got this primitive thingy with all of this how to build stuff in it. That's a node. We've then got the plane itself, which is a primitive. What was a primitive again? Oh, it's a node. Oh, right, okay, I'll sod this. Sorry, but no. Absolutely 100% no. We are not going to be doing inheritance. That's just inheritance suicide. It's a systems analyst's worst nightmare. There's a lot of S's in that. So, what I've decided to do instead is to go back to our first rendering. No. Resources. Let's try that one. See what that one's got in it. This is why I use these systems. Alright, what we got here? Empty, empty, empty. Those are my titles. View controller has everything in it that I don't want. That's good. There's no other files. That's better. Our resources file is in the wrong place. That's better. We'll bring it in here so we can actually get hold of it. Resources have GLSL, and it should also have everything else as well, the ASCII 3D stuff. Yeah, that's good. Lovely. With that, I am happy. Okay, so it's this extension idea where you're extending into delegates, which are it's an inheritance of its own. What do they call it when they're all totally void? It's in my head, but it's not in my mouth. So I'm going to approach this differently. So this is the entry point here. Override func view did load. So we're actually overriding something in NS View Controller. So they provided us a function that says the view did load. What we're then doing is we're calling upon their version of it, the super, which is the inheritance thingy. And then we're adding our own stuff called Metal View, Device GPU, and Command Q. Those things, those three things, we want to do once. What I don't want to do is this here. There we go. We're not doing it anymore. Oh, wait a minute. We didn't test this, did we? Test. Product. Clean the build folder. Not that I know where it is. An instance of Metal is already running. Stop the damn thing then. Clean finished. Good. Run. Build time 32 seconds. Still a bit long for the amount of code that we've done, but it's okay. There we go. We've got a window and it's blue because we've told it to be blue, and that's in here. There you go, 0.5 blue. And it's doing it in metal view, which is what we want. This is called Metal Rogue, isn't it? Main storyboard. Window. Actually, I'm gonna bring this up today. Alright, that's looking okay there. Can we not get everything on screen? What we've got here, Metal Materials Editions, Metal Sandbox. Yeah, we're probably needing some of that stuff. I've thrown that other piece, the scene graph, into the archives, so we've got access to it. Right, view controller, window. Okay, where's that window coming from? On-demand tags. Our first window and commits. Good. Summary of the help. Storyboard ID. My God. Okay, hints. Interesting. Not applicable. It's not going to give me much here, is it? It doesn't want to give me a lot to go on. So where's that gone to? Right, that's the thing that opens up. That's the window itself. That's your first responder. Nothing seems to change here. There's nothing on that one that I want to do. Relationship. View. That's this. Identity. Tooltip. Great. Nothing. How do you actually give it a title? Where's the window title? Can't move that around. No, I don't even know how to get to the window title on this. It's in here somewhere. Alright. So where's the window title? You're going to need two tips. Align, add new constraints, resolve auto layout issues, embed in. I can embed the metal view inside, but I don't see the point in that. Right, so somewhere in this lot we have a window title. That doesn't change. That doesn't change anything. This is the window. Should be in here somewhere. Ah, there it is. Found it. Took up a while, doesn't it? That's the other problem with this system. So it clicks under that one, and we are going to call this window metal underscore rogue. That's its name. And this is dev 0.2. Indeedy, there we go. It's now changed it, so our window should follow. Yes, it does. Thank you. Things are working. That's the way I like it. Okay, don't think I need you anymore, do I? Unless you do something interesting. Alright, we'll get... okay, I'll leave that as that then. We'll close you. Right, so instead of doing... I still need an aspect ratio. Automatic. No, I don't. Right. What I am going to do is do what I always do and make a main game loop. I think that's what we called it. Archive. That's the scene graph one that was just showing you. So under source, in core, I usually put, main game loop. Alrighty. I'll keep you open down there. So what I'm going to do is I'm just going to go func main game loop. And it's going to take in nothing really, I suppose. I don't know what to take in here at this stage, so it's development code. Stay with it. Now, this is in another place. So I'm going to take ulot. It's that func draw in view mtk view. What I want to do is take you. I want to cut you out of there. Place you into here. And see if we can get you to work. So, let's see what we can do. Drawable descriptor command buffer. I really want to put this in a renderer. But first, let's see if we can get this working in here. So, we'd need a bool. So it's a variable. Running. Exactly what I've placed in our prototype. It will be a bool. I don't need to do that. Just var running equals false. Right, so it should know what it needs. It says, but yeah, it's got bool there. Never used. Good. Right, that unwraps things for usage. So the only thing, what we got there, got command buffer. Hold on a minute, that's in the wrong place. Let's move that up. Let's pop you in there. Let's try again. Let's pop you in there. There's a comma. And that question mark goes, isn't it? We've done it. We've unwrapped it. Okay. So, what I want to really say is... while running, do that a lot. Really as simple as. Use of unresolved identifier. Alright. My spelling is not so good today. Running. So, while running, that means it'll just go forever. Will never be executed. Yeah, no. Will never be executed. Why will it never be executed? Because we haven't said main game loop. How can you say it will never be executed now? What's it talking about? I've just called it there, haven't I? Maybe it's got something to do with this in view thingy. I wonder. Let's try that. Missing argument. Okay. And that is metal underscore view. Fix. Don't understand why you need in, but hey ho. Will never be executed according to this. Released without end encoding. Interesting. So, what are you doing? Jumping up and down at me? Sigabort, right. Right, so the Metal API validation was enabled. The MTL debug render command encoder deallocator failed assertion command encoder released without end encoding. That I find interesting. Oh, whoops. Let's try true. So this is doing something behind the scenes that it's not telling us about. Invalid usage because encoding has ended. So on the second time around, it needs to be re-encoded. You are joking me. Alright, fine. This is what we've got to learn. So I don't think we need this because Metal View is being used. We're not using View. I don't know. Let's see if we can get it to work first, and then I can take it out. Oh, right, we've got somewhere. Metal GPU frame catcher enabled. API validation enabled. Metal layer drawable texture. I didn't ask for a texture. Should not be called after already presenting this drawable. Okay. Can we stop? Thank you. ZZ. Going to take you back out of there. Put you back in here. You see, these are the things that you're not going to get out of the manual, unfortunately. Well, not that I can find anyway. Yes, I know you're now becoming a query. Okay. Expected expression in conditional. Closure expression is unused. Oh, sorry. Ooh. We've got another one going up on YouTube. Oh, for those people who don't know, I'm on YouTube. I've just been speaking about this, a lot of code here. If we go to YouTube, we look up some unknown geezer. I'm not getting a thing here. Oh, it is there though. Okay, Fraser, some dude anyway. Me, I think. This guy here. You don't find me. Okay. Let's try looking up Sand Rogue. Do I actually exist? Oh, hell, it looks like I don't exist, people. Sorry. No wonder nobody can find me. Oh, here we go. I'm here. Fraser Sharp. Yeah. I did spell it right then, didn't I? Yeah, you can find me here. And all the code for Sandrogue is in here. Created playlist. 31 lovely videos of googly nonsense there to keep you going. There's a Java 3D engine there if you want it. But you can see that's 19, 20, 21. Yes, it only took 22 days to build a fully functional code base, I'm going to say. Oh, I've got 3 subscribers. Yay, go me. So that's available to you people if you would like to go there. Now, why won't this behave itself? Let's try that again. I don't see a reason for it. Unless this is all now supposed to be view. There's nowhere else I've used it. Because I haven't redone the command queue. This doesn't make sense. Because I'm not asking it to draw anything. No, it doesn't make sense. That should work. I know what should work and what shouldn't. No. Ah. Don't need that. I think I've nearly got it now. Oh, it's still running, is it? Sorry. Can't tell that it's still running. That's the problem with this machine. Right. We've got to get rid of this code, is the answer. Yeah, we do. Right, let's try and be sensible about this and see if I can bypass their stupidity. So under source, under metal, what are we putting? Under OpenGL, rendering. Okay, let's have a file called rendering. New file. Swift, I don't care what language. And we will call you rendering. Now I might have to do it their way. Create. What's wrong with it? Why can't I look at it? What? What's going on? Something's not right. I can't even look at it. I think I know what's wrong. Okay, delete. It's gone red now. Oh, God. Source control isn't working, as expected. Alright. Yeah, because we're on that part of the branch, not that. I can't be bothered with it. Alright, check it out. See if we can add to this one. What? No, cancel. Are you telling me I can add a file and then check out? If you are, then we're alright. Replays. Okay, so I should now be able to commit this. Right, what's he going to give me? All of that lot. All of that lot. Okay. Let's start the prototype. 0.2. So what have you just done to me? Where's the branch? Branch name, prototype. Great. Alright, so we should be on the prototype branch now. Good. Thank you. That's what I like to see. What is going on? Prototype branch created. Please, 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 for the love of God. Let me access the bloody file. And I can't do that. Why can't I do anything? No idea. It doesn't tell me what branch I'm on here, does it? Rendering. There you go. Gives me an error straight off. You may not have this. It is saying. Right, they're all empty. Alright. Check it out. It hasn't though. What the hell are you on? I don't want that. No, there aren't. There's nothing there. So what happened to the other one? It didn't do it. Yep, that's right. Why can't I have files? Don't tell me I've broken Swift already. Alright, that's a prototype. Check that out. Yeah, check it out. That's fine. I'm on it. I'm on the prototype thingy. Let's make a change and see if I can actually add something. Okay, view controller Swift. So it's gone back to this, which is fine. Right, what change do we want to make? Let's just make a little change here. Okay. Source control commit. The one file I've changed. No file to compare. Right. Where's it gone? What the hell's going on? Restore modifications to one file in your local working copy. Keep stash changes after applying. Okay, apply stash. How? Oh, right. Click on it. So why is this not advancing? I can't be working with this. It's ridiculous. You're supposed to be able to branch off anywhere. You obviously can't. It says I'm on master. I want to be on prototype. Can't do anything. Alright. That's okay. I think we can deal with that. Bye. Right, so if I can't do a while loop for that, what can we do? There's the question. macOS app, yeah. Metal. Rogue. Swift storyboard. Don't know what that means. And it won't tell me, will it? Oh, my doc. No idea. No thanks. Yep. We'll take that. Desktop create. Thank you. Right. Where do we start? We start with the storyboard. Main storyboard. Here we go. Hey, this is looking alright. Let's use up a bit more of the screen. Actually, no, I won't. We'll stop it there, because I want to know those. Radio. So, first thing I want to do is change the view. I'll do it. Yeah. MTK. View. Oh, let's get the right keyboard. Is that not correct? Doesn't look like it. Inherit module from target. Nah. That should do us there. And on our view controller, we found it under this one, didn't we? Yeah. So, right. Let's get this rendering going. So that should do that. View controller. Ding. Looks a bit like that. Yeah, looks about right. So, get rid of you. Represented object any did set. If you say so. Goodbye. No idea what it's for, but hey ho. So we need to import. Actually, yeah. If I go into archive, that one. View controller we're in, aren't we? Yep. We'll just open that with a text editor. Okay. What I'm going to do is just copy that out. Copy. Done. Done. So what we're doing is we're going to make a metal view. Yes, I know it's an undeclared type, you plonkers, because we haven't made it yet. Godfathers. We're using the view did load, and we're just putting our red, green, blue. I'm actually using MTL clear color instead of clear color make. I don't know the difference between the two, and well, yeah. But this one gives me red, green, blue alpha, so I'm happy. So we need a rendering device now. So it's going to have to be a class. That's annoying. Okay, fair enough. If it wants a class, we'll give it a class. Where are we? Metal Rogue. New group. Can I give it a name? Thank you. And this will be source. In source, we are going to place our new group, and that is going to be metal, not OpenGL this time. In here, we can put a file, and hopefully this time it will accept it. And we will call the file a rendering. There you go, no beeps, no nothing, fantastic. Okay, so we got that. Now the rendering is going to hold a load of rubbish. So I'm just going to put all the rubbish in first. And then we're going to sort it all out, shall we? Okay. There we go. Saves a lot of typing. Right, that's what I was expecting. So we don't have a scene, because we're not going to be using a scene graph. Goodbye. Depth stencils, I'll think about later. Goodbye. Alright, we just want the bare minimums. Remember, there's no model in here. There's no nothing actually. There's constants and variables. There ain't no scene. Bye. So we init device, yeah. Command Q equals make command Q super init, yay. Model constants, we don't have those. This is true, but we want to keep it. Anything else? Yeah, tons of stuff down here. Oh right, yeah, I've got all this bloody rotation stuff. Model matrix, we don't need. So we have our guard, which looks familiar. That's correct, command encoder's in there. This delta time rubbish all the way down to translations, models and garbage, aspect ratio. Have to fix that. Yeah. We don't want any of this. Cool. Right, okay. Okay, that gets rid of you. Scene render we're not using. Full stop. Oh look what we're left with. Those 3 lines again. As if that wasn't going to happen. But this time it's in an extension. This will run 60 times a second. That I do know. Yep, drawing metal view, MTK view. Yep, that's right. Drawable descriptor, command buffer, command encoder. Those are the 4 things that you need. At the start of this game, we need device and metal view. They only get done once. What's wrong with rendering? R-E-N-D-E-R-I-N-G. That's rendering. You mean you can't find the rendering now? I can. It's there. Has no initializers. Why would I want initializers? Thank you. Go away. That means I'm not initializing them, basically. That's okay, because that's got the pling in. Right, does that respond with a /n or not? No, it doesn't, because my slashes don't work. Where the hell are my slashes? Up here? Oh, it is. Doesn't change colour. Oh well. Never mind. So, got that. We have print, for obvious reasons. Welcome to Metal Rogue. We then create our device. That's the GPU. Okay. No, is it? No, that's the view, that's the screen. Okay. Clear colour. We specify our clear colour. We set a device equal to device. Why? Oh, right. Okay. Fair enough. Yep, because it's a different thing. That's a struct. Right. We ask our rendering to initialize, and then we just set our delegate to the renderer, which should turn our screen blue, as before, at 60 frames per second. Wow, it worked. Nice little Diddy screen to start with, that's nice. So everything's working nicely up to this point, but we aren't in control of the rendering, as you can see from this. So all of that stuff that we had here, ouch, damn it, cat, thank you. All of this wasn't needed at this point in time anyway. Delete. Delete. And that's what we're left with. Now there is this thing here for the aspect ratio. So this is what happens. Drawable size will change. What this does is it governs the resizing thingy. So we can calculate the aspect ratio in here. Okay. So what do we actually need? We need a drawable. We need a descriptor, a command buffer, and a command encoder. Well, we've got the command encoder, so we're one down. We're okay. So I'll title you command encoder, I suppose. This section. I'll just mark it up. Mark you as command encoder. If you wonder why I use mark, it's because it comes up on here. So there you go, command encoder. It's part of the draw because it's in that blue thingy. You probably can't see it on your screens, but it does actually come up on the right hand side, and I can barely read it. I mean, we don't really get to make more space on it to make it bigger, but hey ho. Right, so no selection. Okay, let's try that one. Still says no selection. What about query? Oh good, it will give us things. Right. Now, normally I would do the maths myself. This doesn't seem... Actually, I haven't even checked. Isn't that clever of me? So, Swift library for matrix matrix maths for metal. Let's see if we can get anything at all. Right, so there's the one I've already got. Yes, but how do you put it in? We're going to be using SIMD, that could be a problem. Vector math? Does it tell us in here? Solve systems of equations, factorize matrices and multiply matrices and vectors. Metal performance shaders is the framework. Oh, we haven't put the framework in. Good point. Right, let's do that then. I mean, it works, but it doesn't have the frameworks tied to it. Main storyboard. Nope, Metal Rogue. Frameworks, here we go. Version 1.0, no, it's 0.2. Thank you. And it's dev 0.2. Metal, please. We'll have the metal framework. May as well add them whilst we're here. Doesn't affect our thingying, it just affects it when I stick it on the when I wrap it up to be ported off to the shops, as it were. So there's a third one, which is the one we're just looking at now, which is that performance shader framework. We'll add you. Excellent. Thank you. Right, this is looking okay now. Right, back to Safari. Classes for decomposition and solving. Wonderful. What the hell's a Cholesky? Oh, these are kernels, are they? Solve triangular. That's fantastic. Oh, we have MPS matrix multiplication. MPS matrix vector multiplication. Summation of a matrix. I've never tried that. How to copy matrices. Neural networks, softmax. What about graphics? No. No graphics. As I expected. Metal buffer, ML texture. Well, that's buffers and textures, that. Image filters, neural networks, nothing about graphics. Ray tracing. Oh, yay. We can do ray tracing. Oh dear. Oh, I've got a normalized histogram. Interesting. I wonder why I need that. I could really do with something like field of views and like perspective, maybe. Well, it's certainly put a lot in here. Ba-ba-da-ba-dum-bum-ba. There's no perspective. There's no model view. There's no... nothing. Protocols. Oh, they're templates. I don't know why they call them protocols. Okay. Oh, we've got a code example, drawing a triangle. Interesting. Why do they use ID? What does ID mean? Create an MTL command queue and use it to create an MTL command buffer. I think we've got that far. Right. Okay. Window to the right, please. Thank you. Let's have a look at you. Let's get rid of you. Alrighty. I think this has moved up or down. Performing depth stencil operations. No, I want to go up from that. Down. Let's have a look at this code example. What I'm finding interesting here is, where do you put the code? Okay, let's start here. Oh, cool, we've got pictures. So, the MTL render command encoder, which is currently residing in our here, command encoder. All our command encoder stuff will go here. Right. Might need, I need depth test, not stencil test. Possibly blending. So it's vertex raster fragment, that's fine, primitives, yeah. That's the pipeline for your graphics card. That's how it works. And then it goes through the depth test and blending at last. That's interesting, never knew that. Basically, the command encoder allows your graphics card to do things in parallel. So it doesn't just do one thing at once, it will do the whole lot at once, literally. In the blink of an eye, in a millisecond, literally as well. So this is a graphics rendering pipeline. Alright, so this is our way of encoding our graphics rendering pipeline. So this is your graphics rendering pipeline. Pipeline will come up again, because it's one of the things we're going to need. Somewhere in this lot. We haven't got one yet? No, we haven't. Okay. That's fine. You alright there, Muppet? Are you snozzling everywhere? Yeah, you are. Oh well. So, the command encoder object represents a single rendering command encoder. An MTL parallel render command encoder object enables a single rendering pass to be broken into a number of separate encoders, each of which may be assigned to a different thread. I don't think we need multi-threading. We're making a game, not deep thought. Alright, so we create it. To create, initialize, and use a single render command encoder, create the MTL render pass descriptor. Alright. So let's go out to our initialize here and break out some space, I think, from here. We are going to need what? A render pass descriptor. So it's an MTL render pass descriptor. Descriptor. God, these are wonderful words that they've used. This is an object to define a collection of attachments that serve as the rendering destination for the graphics commands in the command buffer. Brilliant. For that rendering pass, typically you create a descriptor object once and reuse it each time your app renders a frame. That sounds very much like a VAO. Vertex array object. Does, but it isn't. I know that. Because I've already worked out what they've done behind the scenes, and even then they haven't done what I expected them to do. But hey ho. Alright, so we're going to create one of those. We need to create a render command encoder. I think we've already done that. Yeah, we have. It's here. That's okay then. So let's just cycle that off so we can see it plainly. This is where we create our render command encoder. Or is it? Make render command encoder. Must be, because that's what it says. Trust me, just to get a blank screen going was troublesome, to say the least. Because of all the automation within Swift, it's a bloody nightmare. The render command encoder with descriptor method of MTL command buffer. We don't have an MTL command buffer. Do we? Yes, we do. So I've got that bit. Why has that gone out to that point there? Oh, whatever. So that's the command buffer, so we've got that as well. All right, they're doing it back to front. Okay. Okay, we've done the part 2. Part 3. Create a render pipeline state object to define the state of the graphics rendering. Oh, we're going to need one of those. We had told you pipeline had come up again. We definitely don't have one of those. So this is an MTL render pipeline state. Oops. An MTL, a metal render pipe line state. We'll have one of them. What do we need for that? To find the state of the graphics rendering pipeline, including shaders, blending, multi-sampling, and visibility. So that includes all the shader stuff, I'm going to call it. That's how I translate that line. I put it in English. It's stuff to me. Doesn't mean a damn thing. Words don't mean a thing. That's what the instruction actually does on the CPU or GPU that matters to me. And they're not really telling us, are they? For one or more draw calls. Right. Call the set render pipeline state method of the render command encoder, which is down there. Got you. For details, see creating a render pipeline state. Right, okay. Set texture buffers and samplers to be used by the render command encoder. We're not using textures or samplers. As described in that. No thanks. That goes in the render command encoder. Methods to specify additional fixed function state, including the depth and stencil state. So this will include depth and stencil stuffs. That's plural. Because there's other stuff you can have in there. According to this, you can have visibility. But didn't they say that was on here? On the other one. I wonder if they're going to make their mind up on this one. Blending, multi-sampling and visibility. So multi-sampling, visibility and blending are up here. Depth test, stencil test, the one with the dotted lines, are down here. Where's scissors? They are important, actually. Never use them like, but they are important. Oh well, not to worry. Scissors can go to hell. Right. They don't exist. Alright, set textures. Yeah, I've done that bit. Call that depth. Yeah. Finally call the command encoder methods to draw graphics primitives as described in drawing geometric primitives. A nice one. So that's how we do that. Alright. So I've got all the bits now that we need. Shall we get ourselves a couple of vertices? I think that might be a good idea. And some notes. I've already made a section of notes. So let's see if I can explain it slightly better than they can. Hopefully it'll end up at the same thing. We'll check it off with their version at the end of it all. Right. Let's have some fun. So on here, how do I get rid of you? Do I go into the corner? No, I don't. Ah, there we go. Right, so I've looked at you. Right, you've had your turn. I want my turn. I'll use Sandbox, I think, for this. So close that lot. Let's get a Sandbox up. Because it's all in one file in here. Always, my sandboxes are always in one file. And that's here. Alright, so we can open you with a text editor. Like that. Okay, you open with that. Window. Oh, I've got to bring you down as well, have I? For you to give me my options back. And I would like that one, please. Thank you. Right, so some code is on the left, and we have to now translate this into something over here. By the looks of this. Let's see what we've got. So, vertices. I don't really want my vertices in here. I want my vertices in something called floor. Alright, for now we'll stick them in here. Alright, let's put a break line in here for my working area. Actually, does that really work? It doesn't really work, that. We use stars today. And I'll have another one of those, please. Anything that goes in this block, I don't know if you've seen me do this before. What I do is I get a block and I will add into blocks. So these are going to be the things that I will probably move out somewhere else. So, right, initialize mark there. Just move you down one more, I think. Just get you out of the way. So in this block, I want to put some vertices. For our experiment, these are going to be the vertices. It's a square. I don't do triangles often. This is my hello world square. And on this one, we are going to get rid of you, Mr. Texture. Go away. I don't want you. I don't want you. And I don't want you. Don't want no textures. We need a vertex though. So following on from how I designed the C program, I'm going to do exactly the same. All right, okay. Big cough, 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 cough. So under source, guess what we're going to have? We're going to have a new file. We'll have a Swift file. Next. And we'll call it common. This is how I do things, I suppose you could say. Now, if I can get up another file, that would be brilliant. Okay, let's have... What would I put in my common file? Well, I wouldn't get it from here. Probably not from here. Could be. If I've done a common file, I will have put it in here, won't I? Yeah, I will. Under resource. Nope. Under Metal Rogue. Source. Common. There you are. Alright, can we bring you back, please? God, this is an awkward system to work with. Where's my stuff? Alright, just... open Unitex file stuff out. Alright, so it's an import metal kit. We've got some a vertex and some model constants. We'll take both of you. Copy. Thank you. Paste. And I'm taking out you. You can see what the model constants are. Model matrix, view matrix, and projection matrix. Bloody obvious, really, when you think about it. But there's another problem. That we don't have matrices. All the matrix calculations. So whilst I'm here, in source, we will have our matrix maths. No, just maths, isn't it? Sand maths. Thank you. Oh god, this is confusing with all these bloody things open. New group, we'll call it Sand Maths. In here, we are going to put our matrix, copy, finish, and our shader. I'll pop you in there. I'm not sure that I want it in there, the shader. Not really. We'll put the shader in here. Alright. Okay, I'm happy with that. That's a good enough setup. Right, matrix maths, let's go through it. We have float, scale, rotate, identity matrices, and everything. So let's look at them. There's something strange going on in one of these. Right, that's rows. No, columns. So that's the first column, and that's the last column. God, it's on its side. Scaling. Yeah, that's right. Self. Divided by scaling. Divided by, not multiplied by. Oh, right, I see what you mean, W. Yeah. Why are you changing W? That's that point there. That's your Z direction. Something fishy about that scaling. I'm gonna recheck these. I'm not happy with that one. That I agree with. That I don't. Yeah, I understand what they've done now. That's dangerous. Never mind. It's a dangerous one to have. Alright. Rotations. Sine and cos, as usual. Rotations are pretty much straightforward. There should be 3 of them in X, Y, and Z. There you go, that's all your rotations. Rotation by angle. I'm damn sure that angle should be in radians, you know. Again, something to work out. I think it's in radians. I have this little sidebar thing here, don't I? Float. No description. Oh, well, brilliant. So we don't have any descriptions of these functions, these abilities, these mystical things. No, we don't. Fantastic. Can't click on that, can I? There's a rotation angle, XYZ angle. I would tend to use these ones here. So the first 3 I'm in agreement with. After that, very dodgy. Left-handed projection matrix. Is this where they cocked up with the Z component? I think so. I think they got those two the wrong way round. That's a little bit awkward. But it works. So I'm leaving it. I checked it all out, all the maths. A left-handed look at. So you want the camera, which is a float 3 position, the center, and the up. Okay, that's got to be the target. And the up vector is important, yes. That looks okay. Yeah, it's got the dot in. And it's reversed because it's looking from the camera. Yeah, good. That's right. Orthographic matrix, don't care. You can put it in if you want. Converting a double to a float, if you wish. A 3x3 matrix, a float 4, I think that's just so you can notate it. I'm using SIMDs. That's why you want your doubles, isn't it? Yeah, right, okay, I'll use SIMDs then. So hopefully that's everything we're going to need on maths. As you can see, I am not going to spend much time on it. On the shader side, what I've done is I've taken the model constants and put them into C++. This is C++, so it's a hash include metal stdlib, using namespace metal, of course, because we're lazy. We're going to have a struct for the model constants. We're going to have a struct for the vertexes going in to this our vertex shader. Then we're going to have a struct for the vertexes coming out of our vertex shader. View projection. Bye. Don't want texture coordinates. So those are your two structs that we need for going in here. So we've got vertex in, model constants. Then we times it all out, which we're not going to be doing right now. So what I'm thinking of doing is just taking out those middle bits. Yeah, we'll just take these out for a min. Just because we're passing them in doesn't mean we have to use them. Alright, and then I did a fragment 1, which is a base fragment shader, which just gives the colour. Just returns the colour out. And of course there's the textured one, which is incomplete. Goodbye. We won't be using texture, I don't think. But it's there. The basics of it is there. That's just using a default sampler. So I didn't even make a sampler to test it out, because I didn't have a texture. I couldn't be bothered trying to make one. Right, so we've got the bases now of our shaders. What happens is your shaders are compiled at compilation time and held as a library for your code. So we have to set that up as well. So we'll be doing that. That's good news for us, isn't it? What else do we need to do here? Get rid of that again. Right, so I've sorted out that bit, and now it should be okay. Undeclared type vertex, or what's in common Swift. Vertex, position, color. Okay. Really? If I run that, are you sure you're going to crash on me? Build failed. Extra argument in call. What extra argument? I don't even know what it's talking about. Ah. There's that. And now it expects a separator. What the hell is it on about? Let's have a look at this. Yeah, I've taken it all out. All the textures are out. What? It's asking for things that it shouldn't be getting. Oh, wait a minute, double brackets. That's what it's missing. Dope. Wish I'd say. Yeah, this is the problem that I'm having with this language is when you do make an error, and it's bloody obvious that you've made one, it comes up with all these weird things I've never even heard of. Thank you. Goodbye. Right, what's this here now? Expected brackets in expression list. No, you didn't. You're talking cobblers. Hello, Muppet. What are you after? This is interesting. What's it actually talking about? Expected brackets in expression list. I don't think that's the error. I can't see. Does that require a comma? No, it doesn't. That's the end. We are calling that from view controller. rendering device device. That's the initializer. The constructor, should I say. Not happy with Common Swift. It just got a question mark next to it. Okay, is there something wrong here? Nope. Doesn't tell me what the question mark means. We do have a device, don't we? Yes. We have a command queue. Again, that's self dot, isn't it? Okay. So those two belong together. We'll keep them there. And then we init the super, who is NS object. Okay. What does that actually say on the help board? Just out of interest, because I'm not really sure what that actually means. Objective-C class hierarchies. Inherit a basic interface to the runtime system and the ability to behave as an object. Okay. Thank you. Great. Not sure what this is going to say, this. Right. Let's take a look at another renderer. I've shown you through those two files, haven't I? Yeah, the maths, matrix math. Yeah, so we've been through those. Going to this, I've still got 5 errors to get through. This is ridiculous. They have not made this easy, have they? Well, when I say easy, I mean simple for me. Right. So let's have a look in here. At rendering. So MTL device, yeah, that's correct. Command Q, super init. Don't see it. No, I don't understand why it's asking me for that at all. MTL device. Okay. It's not going to give it us, is it? Where's the error? The only thing I've added is that. Open, close, open, close, open, close, open, close, close, yeah, open, close, close, yeah. It's still doing this damn thing, because it's got nothing to do with this. Where the hell's the brackets? Those should be on there. Delta time we don't need, and texture we don't need. And that's those two gone. So I actually don't know what it's talking about. Are you going to tell me why it failed? No, you're not, are you? Ah, here we go. Alright, well, why didn't you say that in the first place? Alright, so you've gone. Thank you. Okay. Bill succeeded. So it was in the shader. And it was telling me something completely different. That's very helpful. Great. I'm loving this. This is an experience and a half, isn't it? Where's my renderer gone? That's highlighting the render and it's showing me the shader. My God. What am I looking at? I don't know anymore. Okay. I've counted up my brackets. You should be okay. One step at a time. At this point, I'm hitting that source control because I'm not trusting things. So... I'll have you. Don't know why it's got a question mark by it. It doesn't tell me. Cancel. Does that make any difference to it? Yeah, it just doesn't. It can't type itself there by the looks of it. That's bad. Commit, don't care what a question mark is. Right, we'll have it anyway. File to compare? Oh, there wasn't. Renderer. view controller. Oh, right, we've got something to look at. Oh, that looks okay. We're on the master branch. We shouldn't be on the master branch, but hey ho, I don't care either. First steps to rendering a square. There's obviously a lot more stuff in here than I would have typed in a full day, so we're really well ahead. I'm quite happy about that, actually. Because rendering in this is going to be a bit tricky. Right, so we've got our vertices. What about our indices? Hopefully we should be okay with these. There you go. So the indices are 012 and 230, which is left-handed counterclockwise. Yep, that is counterclockwise. Top left, bottom left, right, and then it's 2, bottom right, 3, top right, and 0, top left. Ooh, that didn't look good. Are those indices right? Ow. Should be 0, 1, 2, and then you should start really with, alright, we're carrying on with 2, aren't we? 2, 3, yes, that's correct. I think I need coffee. Should we have a cup of coffee? I've already struggled today with this, so let's have a cup of coffee and a quick break. We've been going for a little bit, and we've got people here. I think you could do with a break from me as well, before I start cracking up and gibbering. So how do we take a break? Let's try... Oh, there's a picture of me. Give me 3 minutes. 2 minutes. 2 to 3 minutes. I'll be right back. Good, that's cleared my head a bit. Oof. It's not as warm today. Interesting. Alright. So, let's have a look what we can do. We need a variable for the pipeline state. I'm not doing a depth stencil. We'll need 2 buffers. And that's it. Okay, so I'm going to want you. I don't think it should be a question mark. I think that's wrong. I'll change that to a pling. And I think I'll do the same with these 2 as well. A pling means make it so, as Picard would say. Whereas a query means if possible. I think that's the best way of putting that. I have absolutely no idea what those 2 things mean. But it's in Swift, and nobody's bothered to explain it to me, so hey ho. In my research, my travels and watching videos, wow, nobody's even told me the basics of Swift. I don't really care that much, actually, because I don't really want to be programming in this language for too long. I think just a few days to see if we can get something real. Right, so we're going to... In OpenGL, you have to do your attributes. So I think in the shader, I've already done it. Yeah. So position is attribute 0, colour is attribute 1. We really could do with normals. Shall we have some normals? No, that'll complicate things right now. Add normals after. Okay. That's it's when I can find a place for this rubbish here. I want it to be different than what I've got here, put it that way. So let's have a look what we can do after our initializer. So we get the device. We've already created that, and we send it in. Good. Clear color, we've already done that. Delegate, we've already done that. The device, alright, okay, I was messing about with variables, wasn't I? Alright, so that gives us, yeah, that's done. Command Q, that's done. Have I repeated Command Q twice? No. I only made the device. Device and rendering, yes. That's good. Might have done something right for once. Right, so we need to build the model, build the pipeline. So there's only really those 2 things we're going to do. So what does build model actually do? It sets up the buffers. So build model goes with this, and them 2 there. The pipeline state also goes with all of this. So these 2 things that we're going to place in now, I wonder which one does which. I think it's the second one. So mark build, and it's going to be model. We should really pass the device in for this, should we? For build of a model? I don't think we need to. Oh yes, we do, to make the buffers. We've set a self. Oh god, we've tied it into the renderer. No, that's fine. Right, this is not going to look sensible, but I'm going to do it this way anyway. So what I want to do... not sure. I'm just going to call it a function. Build model. It can decide for itself whether it's private or God knows what. It's supposed to be all dancing thing. What I'm going to do though is I'm going to ask for the device because I want to move this. That's why I'm putting as little as possible in. Right, so what I will do, I need to differentiate it from the one that we're using here. So I'm going to do that. Yeah. Yeah, that'll differentiate it alright. We can pass device straight through though. It doesn't matter which one we use. No, I want to keep... Yep. Yeah, I'll keep it like that for now. Alright. I'm happy with that. It just then allows us to make sure that I'm using the right variable in here so it makes it movable. I want this totally movable. I don't want it to be set here. Vertex buffer, called it the same thing. Device, I've now got it. Oh, not as the same thing. Okay. So this is how we make buffers. In OpenGL, we generate the buffers. In Metal, we describe them, well, we do exactly the same. Literally exactly the same. That's why I thought this was OpenGL to start off with, and it isn't. All I have to do is take GPU off the end, and it'll work. Right, that's generic now. So all we're doing is we're describing the buffer and telling it what's its layout. Well, layout? No, it's memory. We're actually creating the buffer itself. Okay. So that is gen buffers. That wasn't too bad. That has nothing to do with this. How interesting. They didn't tell us about this bit, did they? Okay. Fair enough. I'm just wondering, can I put that above that? Is that legal? Don't know. Okay, we'll mark this one off. Here. And on this part, let's get back on track. We've got our buffers. There you go, you can see it's still on the screen, can't you? Just keep it on the screen. God, this mouse wheel's awful. We're going to do another function which I'm going to keep generic, and this one is going to be a build a pipeline, isn't it? Yeah. Pipeline state. Yeah, we'll have that. We definitely need a device for this one. So again, I want to make this movable. So all of this is just going to get thrown out at this rate. Device. And I think that includes all of this stuff here. But I'm not sure how. So let's just pop this down a line and start hoping that we can find something out about it here. Alrighty, yes, we've got a lot of garbage here. Alright, the first bit we definitely have to do. This I've already checked out, so that's fine. What I'm going to do here is just get our C++ code. And do the wrong thing there, as usual. That one. So, yep. We'll do that first. We'll take the GPU off that to get a device. Oh, sorry. My bad. There we go. Everything lights up. Everything's initialized. And that gives us now a vertex function and a fragment function that we can use in our shader. And if you want to do textures, you use a textured fragment shader, and you put that in here, and you know, you'd add that as well. No thanks, not today. Not for me today. That coffee's nice. Don't want that. I'll have that. I just need to slow down a little bit. What happened to... Have you eaten stuff again? Oh, Muppet, you can't sit on the... Muppet, you sat on a computer. Is that because it's warm? Am I not generating too much heat, am I? No. You are, though. Muppet's decided he wants to snuggle up to the Apple Mac. This could cause heating issues, so if it suddenly goes blue screen, don't worry. The cat's getting warm on top of it. Great. What are we going to do here? Initialize the graphics pipeline descriptor. What about the render pass descriptor? Where the hell does that come from? Have I got it in the right place? No, I don't think I have. So the render pass descriptor is made where? I don't know what the heck that bit's all about. That's the render pipelines descriptor. I think that's what it means by render pass. Yeah, I think that this is what they meant. Yes, that makes sense then. So that note belongs with that code. Initialization, yeah, it was never used. Yeah, okay. Very funny. All right. So I've made a decision on that. I don't think it meant render pass descriptor at all, although it could have done. If we find render pass descriptor a little later on, we'll move it. But we have to set all of this lot, don't we? So this just sets up our buffers, as far as I can tell. So it's this one here. So there's your buffers and your pixel format for the screen, which is a standard 24, is it? BGRA. God knows why they got BGRA. But it's looking that way, isn't it? So that holds true. Colour attachments are on 0. Okay. You can have 32 colour attachments. Really? 8 4s are 24. Yeah, that's right. Unsigned integers, normalized. Yeah, okay. So that's 0 to 1. So it takes it goes 0 to 255, and then it normalizes them. Great. How weird is that? That's what it's saying it wants to do. God knows why it wants to do it that way. But hey ho. Right, what do we got next? Right, we have a vertex descriptor next. And this is where you get the pipeline from. The pipeline descriptor is required to put what we do next into. Because these are the individual buffers. This is when you set your attribute pointer in OpenGL. Oh, it is actually, it's literally the same thing. Okay. So I'm going to take the initialize. So we've got a vertex descriptor. Now, this is why I don't want this in here. May be different per model. Interesting. Because what we're going to do with this thing is all of this lot. Here. Now, if I had done one buffer in OpenGL instead of using different buffers, this is exactly what it would look like with the offsets. This shows you how to use the offsets as well, because we're using a single buffer for both our position and color. They're all being shoved into the same vertex, so everything's in one buffer, but we have to tell it how to split that buffer down. So that's what that's all about. If you notice, we're sending in our attribute 0, which is our position, as a float 3. Interesting. Pudding, I don't think it's tea time yet. Alright. No, it's not. So what we're doing here is we're just defining what attribute 0 is and what attribute 1 is. The format, how far in to start, and of course the stride. And the buffer index, because we're only using one buffer. Out of 32 possible buffers, we decide to use 1. We're also using SIMD. So that float 3 there is going to be SIMD. Can make it a little bit extravagant, I suppose. So once we've done that, that buffer 0 becomes important at this point, so we'll just copy you over. I've already done all the typing on purpose, because I didn't want to be typing all this out today. Yeah, funny. So as you can see, we're now still on the vertex descriptor. And what we're doing is we're just telling it now how big one single unit in that buffer is. Okay, this is layout 0, buffer 0. So that's that done. We now have to add this to the pipeline. So this is where this comes in. Which is why I was a bit mystified about the path descriptor. Doesn't really make sense. So once we've actually defined our vertex descriptor, we add it to the pipeline. And the pipeline will sort that out for us. And it includes all the shader stuff, as you can see, attributes. And all that. Everything's got to match up with your shader. Everything there has to match up with what you're doing in your shader. If it doesn't, you're in trouble. Right. So that's the whole... No, those two don't go there. They go next. So... Sorry about that. This is where we do the biggie. So we'll put those two in, and we will add to the pipeline. Or try. I don't see the point in printing out an error here, because the user of the program will have no idea what it means. There you go. Catch block is unreachable because no errors are thrown. I like that reply. Let's just take that off there and see if it still says that. No errors can be thrown. Thank you. So pipeline state. We defined pipeline state. It's green, so it's here. It's the MTL render pipeline state. It is a self thingy. So it should be self dot. Really? And that's the biggie problem that I'm going to have, I think. Yeah, I've got to put it in. Because that's what it actually, that's what it really is. Well, that pipeline state we can use for everything, so we could leave that in here. All we need to take out then is the other part. Let's mark this up. So I can find it again. Build. I'll just call it pipeline. That's going to stay in here. So the only things I actually want to move out of here are build model and these two. So this is mark data. Yeah. Model data. That's what that is. So the model data and the build model, we need to move out. The build pipeline I want to keep here. We'll only run it once. It's got a device, hasn't it? Yeah. That is just rendering device again. There we go. So that one will disappear. Will it work that way? Yes, it will. Again, that's self dot. I haven't put it in. Yeah. So that really should be that. And that should be that. They are held within this class at the moment. So when we move it, we have to bring with it the variables. Otherwise, we're going to cock up. Right. I'm happy about that now. I think it's programmed properly. The pipeline state looks more like a pipeline state than it did before. Quite a bit of code, but if you remember, there was anyway in the original. We did each buffer one by one. Interesting. Now when we render, things will probably change here. Oh, they'll definitely change here, won't they? Because we now need to do our command encoder properly. So graphics rendering pipeline. And I think I'll ignore depth and stuff until I work it out properly. I'm not happy with the depth code I've done. So I haven't done an aspect ratio at this point, so it's not going to be square, is it? Let's be honest. The other thing I haven't done is in our main storyboard, under window here, ruler measuring. Yeah, here we go. So across it's 900, down it's 500. I'll do that. Just try and build and run that. There should be no errors. There we go. That's better. That's what I like about this. It's very it reacts to you. You type something in and you can just check it very easily within a couple of seconds. That's nice. I like it. I like this idea. I don't like this automation that we've got going, but we're going to have to deal with that as we go, I think. At some point I need to get a while loop in. Otherwise everything's going to come from this extension. Literally everything. Alright, so all we need to do now is get that thing on the screen. Alright, do we look Good there. This is two separate functions, by the way. I thought I'd just say, because it doesn't look like it. All within the same extension. So there's two functions within one extension, two brackets at the end. It's caught me out a couple of times. Right, so we've done the end of it, but now we need to do the beginning of it. What should we put in here? Have we got a command buffer? Yes, we have. So that's EU done with the descriptor, yeah. And then we have mark command encoder, correct. And then we can add the pipeline. That goes there. There we go. Yeah, we don't need you. This is now a little bit weird. We have to tell the encoder that we are going to use a vertex buffer, or our vertex buffer. And we don't need you. So I'll set it up properly this time. So we add our pipeline state, we add our vertex buffer yet again. But now we're telling it not to use any offsets and to use an index. So now we've actually finally managed to say there's an index buffer as well. Great. So have we actually told it what the index buffer is? Doesn't look like it. We tell it at the very end. Here. This is equivalent to a draw call. Well, actually it's not, it's part of the draw call. It's the initialization of a draw call. It's not the actual draw call itself. So that goes in here. So command encoder, we would like you to initiate or initialize a draw call. So draw index primitives, triangles that means. Same as GL, draw elements, type triangle, count, what type of things you've got in there, what it's actually, where it's coming from. Finally we've got the index buffer, and the offset, which we keep putting in as 0. Do you think it'd get the message yet? At this point we've only initiated it. We then tell the GPU we're finished with our command encoder. That's the end of that. We would like you to present the drawable, which is held in that lot, and commit, which means do that. That and that. That's your initialization of the draw call. That's the draw call, and that says do it. Go. Fair description? God knows. And as you can see, the aspect ratio is completely out. You've finished sitting on top of the computer now. You've got it nice and warm. I'll give you that, love. You now want to sit on the pen tablet. You're fantastic. You're a really helpful cat. So you can now see that it's nice. Our square is nicely stretched out and having fun. But we got it on screen. Now what I want to do is duplicate that without the renderer holding the object, the floor tile, because that's what it's going to be, a floor tile. Right. And I have no idea how to do that at this point in time, so we're going to sit back and relax and chill and find out how to do it. I'll keep that opened up, I suppose. And that's it, folks. That's how you draw. That's your Hello World Metal. We have just completed Hello World Metal from a lot of research, that half of which was wrong. Yes, I had to rewrite the research twice before I got it right. No, I'm happy with that. I know that we want to keep the command encoder here. And I know that I want to keep the draw here. Because if anything goes wrong, this will catch it. I hope. That's what it's supposed to do. Now build pipeline, build model, and model data we can play with. Where did we put our floor last time? I think we did put it into the OpenGL part, didn't we? So what we got now then? Let's have a look. We have all we've altered. Oh yes. Our Hello World square in purple. Well, purple gradients anyway. That's the colours I use. Use exactly the same colours as before, everything. So you want to note down the model data, the colours. I use 0.5, 0.5, then I use a full 0.5, 0.5, 0.5, and then a full 0.5. So it has that gradient fill feature to it. Yeah, funny. So you get your grey to purple to grey gradient fill. I use that so that it helps me find where the squares are when we put it onto a map. We make a floor, like into a floor tile. That's the only reason why I do that. Using SimD3s means it's multi-threaded automatically. So this will spread out across your GPU and be electric fast, which is useless because it's 60 frames per second bound by this rendering method. This draw call only happens once every 16 milliseconds, interestingly. Right. Let's think about this. Before the cat sneezes all over me and I have to have a bath. Oh, we got messages coming in. Let's just have a quick look. Oh, my Twitch export to YouTube works. That's good news. And it tells me that my microphone's working. That's good news. Thank you, Windows. I will say one thing that Windows does not have. And that is the attitude of caring for the user, which I have found the Mac does have. I mean, if I put Siri up on this, it would go mental at me, probably. Be so helpful. I'd have web pages popping up all over the place, probably, knowing my luck. And dedicated music channels, and all these helpful things. Every time I open a window, it's usually got things there that I want. It's quite interesting how they've done that, but it's what you're paying the money for, unfortunately. You're not paying it for the hardware, I can tell you that. I mean, it's fast enough, but it's still something... the hardware, funnily enough, is slower than the Linux machine I was using. But you can see how fast it reacts. It's very well made. The software side is very well put together so that everything works fast. And immediate response. I mean, this thing has less memory, less hard drive space. It has less everything, less CPU power, less graphics power. I mean, there's no graphics card. It's just an Intel i3 with onboard graphics. It's using the Intel i3's graphics part. Graphics on a chip thing. So there's nothing special going on. In fact, all the parts that are in this, you could have probably got for around £900 in 2010. It's the software that makes it work. Which is why I'm not trying to break the rules for once. Well, up till now anyway. And yes, when I run it, it does actually come up with "Welcome to Metal Rogue." Wow, what an achievement that was! It took me 2 days to work out how to do that. Well, hey, Right, so what I want to do is move towards the original. Idea. I want to make a floor. Now, this is actually quite interesting. Because in the original one, it was a scene. Whereas this time I want to give it access to the floor. Now, no, I don't want to do that yet. I want to see how I did it down here first. we sent the command encoder across. Well, that means it would have drawn itself. That's not what I want to do. To be honest. What I would prefer is for the things that this needs to be taken in the same way as we did it last time. Where we would tell the renderer, hey, we've got these like lists, these vertex lists, or a list of objects that we want rendering. So this is where the interesting thing comes in. So where is the original? It's in Sandrogue. It's under source, and it will be under OpenGL. And it was called Sandfloor. Okay. There it is. So let's try and do whatever we've got here. Let me just change the name on this. Oops. What do we... Oh, metal kit. Stupid me. Now, Swift is based on Objective-C. Objective-C is based on C. You can return tuples in Swift. We might not need a game model. I have no idea how that would work. But I would prefer this. But you can see how it's the same. But it's not a class. Oh, there's a cleanup as well after it. Okay, return floor, yeah. Oh, well, I didn't know I could do that. You can't get hold of the left-hand side. Alright, okay, that's comical. So as you can see, index buffer, vertex buffer, exactly the same kind of stuff going on. You can even see element array, index array 0, index array, vertex array 0, vertex array 0, God knows what, normals. Yeah. So this is all the same kind of thing. But what I'm interested in is this struct. Because what I would like to do is make a game model. Now, to make a game model, what would we need? An awful lot of luck. We need a pipeline state. We could leave that in here. A vertex buffer and an index buffer. Do we take the pipeline state out? Well, according to this, yes, you do. Then that's what we do. Those are the 3 things that we need. And we're going to call it game model. Alright. Let's go up to the top. Oh, look. Yeah. That worked out well. I didn't plan on that, by the way. So we are going to have a struct. Called game model. I like it when a plan comes together. And the game model is going to have whatever we need. Cut. Paste. Do I need all those plingy pling pling things? I doubt it. We'll take them off for now. Alright, let's see if I can do this. Right, let's just go for it and see what happens. I think that'd be an ace idea. So game model. Got it. Nearly got it. So in our renderer, we would hold a game model. This will translate later. So where we've taken that out, we now say, is it a var or a let? Is it a constant? You see, a var makes that into an array. If you put a let, it makes it into a vector. Wonder how it works with structs. We've already used vertex, haven't we? Well, you can see now that it's complaining a little bit, which is fine. Right, so we replace the word self. No, this should be okay. Yeah, alright. Var game object. Equals game model. But I done it wrong. Alright, I'll just put that in there. And that will contain the 3 magic words. Pardon? What? No, don't do anything yet. Just keep it as an error whilst I work it all out. Right, so that hooks in there. Sand floor will be a function called sand floor tile 3D create. God, I have fun with this, didn't I? Sand floor tile 3D create, and an arrow to a game model. Oops. Is there no space there or what? It's an arrow, I know that. What? All right. Is that closer expression is unused? Okay. Var game model. Just do exactly the same as before. Equals game model. Yes, we know. We know. What if it's supposed to be a colon? That might work better. We'll see. What do we need next? We need to go back to rendering and take all that information out. So everything from here. Oops. Better stop at that point, hadn't we? We'll cut you. And we'll paste you here. Alright, that might be okay. Yeah, keep going, keep going. Don't think about it, just keep going. Keep thinking about it. We're going to take you two out of here. So that's you done. Indeedy. So where we've got the word self, I want to put game model. Yeah, did you mean to use equals? Thank you. Okay. Copy. Do I actually have to put nil in there? I'm not sure. I'll leave that till last. I'm not sure how the variables are going to react in this. Shift plane, maybe. Okay, you can't get the unwrap. Yep, that's fine. Right, so we've got that. Game model seems to work there. There is another self here for game model. Catch block is unreadable because we don't have something. Where's the error? Game model.pipeline state. That shouldn't be a problem. It's unreachable. Ah, device. So how do I get the return? Okay, we haven't got a return here. That's a good point. We would then just let's have a look at this. Do open, close, close. Get rid of them. Might help. Alright, we've still got opening brackets, have we? Yeah, we have. And yeah, we have. Okay. That should ease. Oh, wow. Yeah, we need a device. So how do we get the device? Alright, it's not happy about that. Device colon MT metal kit. So MTK. No, MTL. Yeah, there it is. Unused, undeclared type. Oops. Right, missing arguments. Alright. Fix. What are you on about? Okay. Where are those? Ah, yes. They are in... Do I have to define them? Yeah, I suppose I do. Or not. How's about nil? What would you say if I didn't want any of them? Would you complain now? Yeah, probably. I don't think it's done like that. I thought it was done as a return statement. Nil is not compatible. Alright, fair enough. It's worth a try. Let's try that. Alright, so we got model data. Next, we need a device. Okay. We've got one coming in. It'd be let, I would think. Floor underscore device equal to device. Okay. Alright, who's complaining? You. I think we might be getting somewhere. Oh, right, we're at this point, are we? Right. Right, okay. Double check. Rendering. Gotcha. It's an MTL device. Bing. And then we just self. There is no self, is there? No. Floor device is equal to device. There's no self because it's not a class. Right, that should now work down here. No, it do not. Oh, wait a minute. I'll just do that, can't I? So is it a query? Or... I think it might be a query. If it is, we could be in trouble there. Cannot force unwrap. Do we have to guard this? Let's have a look what it does. Okay, fix that then. Where did it put that then? Oh right, puts it right at the end. Well, I didn't see that one coming. So to make it work, all we do is shift that. Ah, can't do that, sorry. Right, let's get this floor device working. Unresolved identifier. Unresolved identifier. Don't tell me you're a pling at the end as well. Christ. No. Query. No. Don't like it. I think we need to unwrap the floor device. Yeah. Just in the same way that we have to do it in the rendering. Alright, so it would be guard, else return. Okay, that kind of thing. So, is it guard or guard? How do you do the guard? Sorry, I just looked at it and I can't even remember what I looked at. No, okay. Guard, else, return. Okay. Right, build model just cleared itself. Ah. Initialize of a conditional binding must have optional type, not MDL device. Je ne sais pas. I don't think we need any of this. I just realised we're not in a class. Device MDL device, yeah, okay. I think I'm wasting my time with that. Totally. Is this pling thing again? I don't understand why it's doing it. This is part of the problem is I don't know the language well enough. Anything? No? Can't query it. That's not right. Oh God, what do you do? What do you do? What do you do? I don't know. 3 expressions are not allowed. That's an interesting one. Never heard that one before. If it's just a query there. No. Why is my CPP libraries coming up in green? Device isn't. You see, that's the way I would do it, but you can't use a self. How weird. This language is very weird. I can use a device like that, but I can't use a device like that. It's not giving me help. No quick help. Well, thanks very much, mate. What I'm wondering is, do I have to put... No. This is ace. Oh, I can convert it to the traditional Chinese. That's great. Great man paging terminal. Fantastic. Extraneous at top level. Why does this act so weirdly when you suddenly put a real function in? Return invalid outside of a func. Huh? How come that's outside of a func? I thought it was in a function. Where have we stopped being in a function? There. There. That's where. That's what's happening here. Thank you. God, fathers, we found it. Jesus. So now the device works. We have a lot of yellow. Used before being initialized. This isn't right. Index buffer's never mutated. What? Okay, you go ahead and expected an expression. Like what? Oh. I've left one of those lying around, have I? Oh, the top ones have now shut up. And now all the bottom ones want to complain. Instance member vertex buffer cannot be used on type game model. What? Yay, I like this language. Don't think dot self's right, you know. Constructor call after type name. That means you want brackets. Alright. Can we query it? Cannot use optional chaining on non-optional value. I just want a variable, that's all. All I want is a variable. No, there's something not right here. This is so weird. Missing argument labels. Oh, I see. I think I've sorted it. I've got it right in my head now. I've just done it the wrong way round. This doesn't belong here. At all. It goes at the end. Done it the wrong way round. Here's your index buffer. You let that one. And there should be another one down here. Alrighty. Now we can construct a game model, can't we? So we can now let game model equal a game model struct. Oops, what did I just do there that was wrong? With that lot in. So, pipeline state. Oops, did that wrong. Pipeline underscore state. Why aren't you doing this? Will you stop moving? What the hell happened? God's sake. Pipeline underscore state. That's all I wanted to put in. The vertex buffer is a vertex underscore buffer. And the index buffer is the index buffer we just made. That's it. And I don't know what you're doing there. Or how you got there. What's wrong with it? What? Are you taking the piss? You mean I've got through all of that to find an unresolved identifier in a pipeline state? Which means we can't put the pipeline state in here, we can only do the vertex buffer and the index buffer. Damn you, damn you. I don't know of any way of resolving that. So you can't force it, can you? No, you can't. That's a bloody nuisance. Ah, wait a minute. We would have to initialize it from something. Let's try this pipeline state out again. Now I can force that. you I can force. Oh. Right, I think we've done it. Yep, we've done it. Oh heck. Lots of warnings, but we've done it. What an interesting journey that was. So we now have a function that makes a game model. Or so it says. But does it? And do I ignore warnings? No, I don't. What to do, what to do, what to do. Roll with it. I want to give it a test. I think this piece of jiggery pokery and hacking needs testing. I mean, that I don't care about. So we can get rid of those. I think, no, we can't get rid of that as a variable. We took it out as a variable, and it never complained in here. Because it got used there. Let's see what happens if I call this thing. With a device. Oh, wait a minute, did I make one? I think I did. Where have I put device? Rendering device. And that would be... I'm not liking what I'm seeing. Why am I not liking it? Oh yeah, we've got the same thing going on up here, haven't we? It's in the wrong place. We found that out. Okay, then do that. I'm not bothered. Alright, so that now works. Oh dear, it seems to work. Am I a genius? Have I just invented a new language within Swift? What do you mean there's no class? Well, it's just a bloody function. Does it have to be static? Oh, you're right. Doesn't have it. We don't have the indices count. Oops. So we need that game model dot indices count. Where's the indices count gone? We lost it. Yeah, we have. Let's head out to you. And we'll have a variable indices underscore count. And that will just be... I haven't a clue. What will that be? Oh, what did it used to be? Are you going to tell me? No, you're not. It's a uint 16. Yeah. Gotcha. Can't be any larger than that. So that solves that problem. Meanwhile, back here means we have to add it. Alright, I don't think it's caught up with us. Just let's have a look at common. Right, yeah. You've caught up with me now, haven't you? Thank you. And what does that equal? Rendering? Right, now. Int. Thank you. No. Thank you for being helpful, but no. I know it's an int now. Change it here, not there. Great. Stupid machine. Right, you'll be happy with that now. Just take the comma off. Return game model, and in rendering is indices.underscore count. There you go. Can't think of anything else I need to cover. That's just to put a square on the screen, huh? Ooh. 105. Fatal error. That pipeline state ain't gonna work, is it? Right, so at least we know that now. We can't calculate the pipeline state outside of the renderer. I don't think we can. So what we'll do is we'll scrap it. Yeah, it's nil. I know. For some reason, which I have no idea of. So I'm going to take you out, and that'll do that. Common. You get cut from there. You go back in the beginning of our renderer. Oops. Back in the beginning of our renderer. God, Control. No, that thingy. We put a little doobry on the end of you, just to make sure. And then it's self.pipeline state. Yeah, I remember now. So we can bring you out of there. Can we stop the fatal error, please? Thank you. And no, there isn't a missing argument. You come with me. Actually, the whole of you come with me. That was a shame. We tried. But rendering, I'm sorry, you're going to have to build this whether you like it or not. So it comes straight after here. It's here. If I do space, and it's build pipeline state. So it's func. Actually, it's private. Build pipeline state, device, MTL. Device. Why is that an error? That goes back in there. A self dot. Oh yeah, I remember why now. We might want one of them. And one of them. Alrighty. It's all out of alignment, but I don't care right now. I just want to make sure everything will work nicely and play nicely. So now we have a device, and we have our repaired pipeline state. Which goes there now. Isn't that interesting, the way that that went around the bushes a little bit? Alright, so you look okay now. And we have accessed all of this. Works. Bloody hell. So no, we don't need classes. Right, that solves the problem that I was having with this language. We've just solved everything, the whole thing. All we've done is we have copied these. Are they going to... Yeah, okay, let's get rid of them. For now, let's make this into a proper thing. Let's get rid of all warnings. That'll change later on. Don't need that. We ain't got one anymore. Ha! Suck on that, Buster. I don't even know this language, and I can still make a function. How ingenious is that? Oh, by the way, this is the first time I've ever tried programming this. If you're interested. Yeah, that looks like a... It looks a bit more simplified than that, but it's still got the data. We haven't got the normals in. Whoops. -5.5. Alright, we're doing it in the Z direction, aren't we? To stick it on the floor, but I don't have a camera that I can move. We'll come back to that. I think that's brilliant. Okay. It's our first sand floor tile. Needs a bit of cleaning up, but hey ho. And I'm very, very proud of that. It's taken a lot of messing around, but now I know where the code for the sand floor tile is. It comes under sand floor. That's fantastic. That means if I can do that, remember we still have the same rendering, as it were, with all of this gumph in it, and we still have the same draw with all this gumph in it. But if I can get a game model out of the loading up on the I/O side, hello Muppet, then we have cracked it. We certainly have cracked it. Because all we need to do then is do a second pass for the other, well, we can do it exactly the same way as the other renderer. Yes, we can, Muppet. We just have to try. Okay. Muppet says, no, I want to blow my nose all over you. Thank you. So yeah, we have done Hello World and gone beyond the Hello World. We have made it into the realms of Sandfloor tile. This was always my problem with people demonstrating how to do the Hello World business, was that they never demonstrated or went any further with it. That's why I've dedicated this part, this Hello World part, to each and every operating system that we use to make this game, because we're going to use all three. We're going to use Windows next, which I am dreading. Windows is actually the hardest, I think, out of all of them. I'm finding Swift strange, but not unmanageable. It still follows the rules of C. You just got to get, well, order matters. Getting things in the right order. Damn shame about the pipeline state. I really would have liked that in its, if anything, in its own little tidy function somewhere, not doing anything. And we can just get rid of it and forget about it. But we can't. Life is not going to treat us that way today. So instead, what we're going to do next is work on getting the main game loop, I think. Because at the moment it's automated. Now we can use that to our advantage here and put the main game loop in that automation. But we have to be careful how we do that. Because at the moment, what I'm going to be doing is trading things in and out of the renderer. The renderer is going to be the game loop, which is ludicrous. This is an absolute ludicrous way of programming. It's completely on its head. It might suit a scene graph where everything draws itself and extends out from a renderer, but it doesn't really go with our ideas. So I think I want to try and break out of that a little, but I'm just wondering how to get back into it afterwards. Now, the way I used to do it in Qt was use a timer, but that ain't up for grabs here. So what I'm going to do is I'm going to run the main game loop straight off the renderer. Muppet's looking at me and saying, you are going to do what? Yeah. I'm going to globalize a load of structures and chuck it all up there. We'll chuck it into global space to start off with. And develop it from there. Now, I was thinking of developing the ECS a bit more, but instead what I'm thinking of doing is something slightly different. It'll be ECS and it'll be 3D, but it'll have nothing to do with that floor, which we might use later. Now, I coloured that. Yeah, colour pickers and stuff like that. Are we going to bother with them? Not really. I'm not bothering with anything that wasn't in the original. I've already got 3D graphics here, for God's sake. The original game was a lot simpler than this. But what I would like to do, considering we do have 3D graphics, is to at least attempt some kind of GUI. I I don't think I want to use the floor tile though. I think I want to load something. It does open up the possibility of texturing, but I'm trying not to. Texturing does complicate things a lot. And at the moment, every time we are going through that renderer, we create a new game model. Have you not noticed? That game model only lasts until that scope has been reached. That's how long it lives for. Where's that information being held? That's being held on the CPU side, isn't it? So we need to introduce our ECS. That's for certain. Was that ECS core? Or am I going to clean up this with matrices? I'll put the matrix maths in for it. What do we think? Do matrix maths next? Well, that's going to not take too long, is it? No, I've already got the code for that. It's here. So no, it's not in this one, it's in another one. But we now have that kind of structure going on, except for the fact that all of this bits here, all the buffers and everything, are stored in here. Pipeline. So they're like prepared for us. I actually find that interesting. And that it works. I do seriously find that interesting. Because I was told that Swift was the all-dancing kind of thing, but it isn't. It's just like any other language. But it's very verbose. And I don't know why. And on that note, I'm going to end the stream, I think. Next part of the stream is going to be ECS, definitely. We're going to need some kind of componenting system. Now I know we can build one. That's what that was all about, by the way, making Sandfloor.swift. Was all about seeing whether or not we could build something. So we went from Hello World to Sandfloor tile. Wow, in one day. That's amazing. Right, so next part is going to be introducing parts of a basic ECS. We've already got our struct file going. We've already got common going. There's just no includes. We can put our enums in here as well, I think. Yeah, I'm perfectly happy with that. Absolutely happy. I will do a code review and tidy this up. And I'm going to throw away that altogether. I'm not even going to comment it. I'm just going to chuck it away. I'm going to do the same with the shaders. Now I've got rid of it all. I just don't want it in here. I don't see a need for it. It's one of those nice optional extras that we just don't really need. I mean, look how simplified it is. I mean, lighting's going to be a doddle because of these model constant things. Yeah, that's okay. That's all right. It's cleaner. That's a lot cleaner. I think I prefer that because this is going to grow downwards, obviously. Right, I'll go and tidy up the files because they're all a bit splattered now. I tend to do that. I tend to splatter files as I go through. But hey ho. Yeah, that's right. Okay. I'd like you all to take care. I'd like to thank anybody who's joined us. And if you're learning something from this, that's fine. If you're not, let me know and I'll do something more along the lines of what you want to learn. I'm not bothered what I do. I'm learning. So that's the important part for me. I've never done Swift before and I'm quite enjoying it. It's a bit weird in parts, but I'm enjoying it. So I'm going to go and do some more research now. And make sure that I can do ECS properly. I might do some typing for that as well. So in the meantime, I'd like you all to take care. And I suppose I should really be on a different screen now. That one. So thanks for popping by. Enjoy the rest of your day, enjoy your evening, and pop over to YouTube if you want to see the other stuff, where all the code came from, how it was developed, and have fun. Oh, I can now press that button.